Hi, I'm Tresta Neil with Called to Learn, and today we have Dean Sessions with us on our interview, and he's the author of The Universal Model, a new millennial science, and it was a book and a work that was introduced to the public in 2017. Reading these volumes has been an illuminating and enjoyable experience for many truth seekers and many homeschoolers, as abundant light is shed on how the earth and life and the universe came to be. It not only disproves much of the inconsistent, foundationless, and pure theological and unscientific ideas still taught today, but promises the opening up of many exciting new ideas and studies. Although the work is scientific in nature, readers may find their faith in God and scriptures increased. Yes, the UM gives evidence that there was indeed a great universal flood, a flood that amounted to a second great creation process that explains for the first time how rocks, minerals, and gems are formed. And that's only the beginning. Dean Sessions will show us in simple concepts that once we begin to understand the order and the beauty of nature and life, we find so much more to enjoy and appreciate and to share. Dean, thank you so much for being here with us.
Hi, Tressa. It's great to be here too.
Thank you. Well, I'm excited to get started learning then. Why should we teach natural science to our children?
That's a really good question. So the word science itself, it means to know. Okay. Mm-hmm. And what is knowledge? Well, knowledge is it's a part of a definition of a very, very important word. We discussed this in the very first chapter, and that word is truth. Okay. As far as I know, I have not found a scientific textbook yet that's ever defined what truth is. And we do for the very first time define what truth and scientific truth both are. Truth is the knowledge of things, and we actually simplify this out. Truth is the knowledge of what is, was, and will be. So truth is knowledge of things that don't change. When I throw a rock up in the air, it's going to fall at 9.8 meters per second squared every time in my location where I'm at. So this is the law of gravity. I don't throw the rock and it just keeps going up in the air. It doesn't fall at different rates. There's a constant consistency of nature that is really, when I was in high school, it was really an exciting thing for me to learn and find out that there's natural laws that are applicable all the time. And that's really what the goal of science is. True science is about finding natural laws that demonstrate nature by explaining and helping us understand how everything in nature works. So back to your question about why we should be teaching science to our kids. Well, first off, learning what truth is, like we just explained, and then being able to go into each of these fields and find the truth demonstrated through scientific experiments that we can all reproduce is very, very important. What this does is when we start understanding real science, then we find that there's a different understanding of who we are and where we came from that's taught in modern science. So when I use the word modern, these are parentheses around it, what that's referring to is what most of your textbooks and your movies and the culture that we have all around the world today refers to modern science. Now that's kind of an oxymoron actually, because science started back in the early 1800s. That's when the word science was used. Originally it was philosophy. And science itself, if you were a philosopher, you'd start studying and knowing all things. But science, the word science, which means to know, actually started back then in the early 1800s. The problem was, though, that the original scientists like Newton, Galileo, and Kepler were all really good at experimentation, and they actually all were Christians. They believed in God, and because of this, they were able to find new natural laws, And we still use these, like I mentioned, the law of gravity today, even though that was hundreds of years ago it was discovered. So one thing I like to ask the students, and this is kind of important, is in your lifetime or your parents or grandparents, how many new natural laws do you think have been discovered?
Probably not very many, huh?
No. And matter of fact, see if I can find this in the book here. I'll refer to a couple of these things in the book and tell you what page they're on in case people want to look. So what I actually did was we found this particular book. As you can see here, it's 100 Scientists Who Shaped the World History, page 45.
Okay.
So this book is in chapter 3. We took the 100 scientists that were in there, and what we did is actually we put them on this chart. If you can kind of see here, this chart, it shows 4 different areas. So we have new observations, new technologies, new theories, and new laws. And this goes from, the millennium, 2000, all the way down to 500, down to 500 BC, all the way down here.
Okay.
And so what I have here is you can easily see, I want to get the light on there, right? This column and this column are all filled in the whole time. Okay. But when you come over here, then these are observations and technologies. So throughout time, science has been making these discoveries.
Yeah.
And that's what each of these are. These are all of the 100 scientists that are in that book. It's a compilation of all of what they've done, what they became famous for.
Okay.
And the third one, though, over here is the theories. And if you notice, there's a whole bunch here about the last 150 years, but before that, there isn't any down here. We asked the question during these time periods, what happened to all the theories? Well, they were either moved over to this column, which is the natural law column, or they were discarded.
Oh.
Except for when you come up here to the last 100 years. There's nothing in there. Very interesting, because this is called the scientific dark age. This is a new term that we had to come up with, because we got through some real simple questions. Do we have more scientists than 100 years ago? Obviously, yes.
Yeah.
Do we have more technology than 100 years ago? Obviously, yes. And do we have more money going towards scientists? Yes. So more money, more scientists, more technology. Why don't we have more new natural law discovered?
That is a really good question. Because we don't want to find anything?
No, we have millions of scientists out there today, and their whole desire, their whole career is, to make a big scientific discovery. So the desire is there. The problem is, in the last 100 years, modern science has gone from looking for natural law to making theories. As a matter of fact, in our book, we have a quote.
Theories are the endpoints of science. Wow.
Theories. So see, the endpoint, that should be, of course, the natural law, because that's what we all can test ourselves and make sure it's real and everything. The theory is what you start with. And that's where they're ending, is what you're starting with. And this is where modern science has gone off base, is they're not looking for natural law anymore. The reason they can't look for natural law is because natural law is simply a statement of truth. And they're not looking for truth.
Yeah.
Because even though the early scientists were Christians, the scientists today have taken their own survey, and 93% of the leaders, okay, so these are the leaders of science, took their own survey. They published this in Nature, the journal article of Nature, and in the Scientific American, and 93% of the leaders are either atheists or agnostic.
Wow.
This presents a real challenge for the typical parent who has a faith-believing person, because you have now the people that are supposed to know a lot, the scientists are supposed to have this vast amount of knowledge, not believing any type of creator, and they're teaching your children when you go to college. This is it's over 90%. Matter of fact, the second volume I'm working in, I have journal and research articles there showing that there are entire colleges that don't have any conservative teachers, at least no Republicans of record. In the entire college, they're all Democrats. And so the liberal view is over 90% in most schools is being taught. And therefore, if you're trying to go take a political science class, for example, you can't learn the conservative side. You get way put down if you mention about conservatism, because everybody's liberal. All the teachers and everybody are. So this is a real problem, because this translates into science where they're not able to find things like natural law, because it's a statement of truth. And of course, that goes back to things being concrete. They have to be one certain way, and that's what natural law is. And find that the typical scientist is not wanting to go that route. They want to have a theory, and then after a while they make up another theory and another theory. This is what the Big Bang is. Matter of fact, I'll show here in this little book here in the summary. We got a little nice picture here. This is, we'll get this out of the way. It's called The Big Picture of Modern Science. And you can see that right there. Okay. So the big picture of modern science shows mankind at the top there, and we came from an ape-like creature, which came from a bacteria, which comes from chemicals, which comes from the Big Bang, which comes from nothing. You and I and everything else around us came from nothing. Now notice the two theories that it's from. It's the theory of relativity and the theory of evolution. They're not laws. You don't have the law of relativity. You don't have the law
theories.
They're theories. And they know they have to call them theories because no one's ever observed these things being true. Matter of fact, E equals MC squared is not a correct formula. You can't go in a physics class and demonstrate that formula. Einstein's theory is not correct, and neither was Darwin's of evolution. You can't find a new species in nature, like behind me. I'm in the mountains of Montana right now, really enjoying it up here. I'm from Arizona, and it's a little warmer right now in the summertime down there. So I'm enjoying the cool weather up here. But in nature behind me, we can't find any species that reproduces into another species. It's never been, the speciation part of evolution has never been observed. And the same thing goes in the laboratory. And this is all documented, by the way, in our book here. Each book has over 2,000 journal articles that are all referenced in each one of these books. There's 3 of them. So that's 6,000 references, roughly, that we have in all of our research that over these last 3 decades.
Wow, that's incredible. Incredible. Well, thank you. So tell us about your very, very first discovery.
Okay, our very first discovery was actually from 1990 to 93, and this is when I was just first getting into science. I loved science when I was in school. When I went to college, I was originally a physics major. But I'll say this before my discovery, because what happened was, what I had learned in high school, I had a great physics teacher who we performed experiments in class, and it was just a fantastic experience because everything we did there was demonstrating what was correct and what was true. But when I went to college, because it was an AP class, we actually were using the same textbooks, and the teacher just stayed up there and wrote formulas on the chalkboard. And for 3 weeks, he went on and on just talking and writing formulas, never actually showed anything, which I want to do today. I got a whole table here full of stuff, and I'm going to show you guys some stuff, okay? For example, how rocks are made and that type of thing. But the physics, it just really discouraged me, and I ended up finding out I wasn't supposed to major into physics at the time because we went to go do an experiment, and the class was actually, it was a lab. We didn't do anything in class. We went to this lab and had this big table, and you went in there, and everyone just stood around and looked at it and wrote down, what you observed. That was it. I mean, that was our experiment. And I was just so discouraged. It was like, wow. It was also theoretical. And so that really changed things for me. And I ended up going off into another field. I was in real estate actually for quite some time, did everything in real estate. But that was very important for me because it helped me recognize how to research. This is what your students, especially as homeschoolers, need to learn to do on the internet, is how to do correct research. Like when you're doing a Google search, for example, they actually have where you can go into the scholarly research. And this is really good because you want to put in the keywords to find, there's billions of articles out there, and you want to find specific articles on specific things. And you can go into the scholar research and look up just journal articles. And so this is something that the kids and the parents can help them learn, because they really can't go in and start learning unless they know how to do proper research.
Yeah, yeah.
So this is what is really, is for example, I used to be an appraiser, and when I would appraise a house, you have to have comparables.
Mm-hmm.
And your final value, estimate of value of the home, is only as good as those comparables. So you
Yeah.
have to find the best comparables that are most like your house and see how much they sold for, or if it's commercial property, how much they were leased or rented for, and then
Mm-hmm.
you're able to calculate and figure out how much the value of the home is. So it was very similar, and this helped me understand that I could do what any other scientist was doing. It took me 10 years, from 1990 to 2000, to learn all the things that are in the universal model and all these fields of science. And then in 2000, we started writing. But
It's pretty incredible that that your real estate helped you with the scientists. I loved how you made that comparison. That's pretty impressive.
Yeah, it was interesting for me to see how that all worked out too.
Yeah.
But what was really interesting was this very first discovery that we did deals with archaeology. And I'll just say real quickly how that actually happened. When I was a child, 8 years old, my dad had found 2 artifacts. He's from Wyoming. Just when he was a kid. And I remember him showing me these. He had kept them in his little box, and I held them in my hand. And I remember how neat it was holding something that was thousands of years old, and realizing this arrowhead either killed a deer or a human being. You know, it was a big animal or person, because that's what it was used for, to make that arrow and to do that. And I remember going out and trying to find some of myself, and I wasn't able to do that. And so it caused me to kind of neglect, or not really get into the archaeology as much, because I couldn't find any. In Arizona, there's not very many at the time. But I was once again with my family on a trip when I was doing an appraisal, and we went into an antique store. And of course, antique store, everything there we thought was for sale. And I asked the gal behind the desk, how much was this big, huge frame of arrowheads cost? And she looked at me and laughed, said, "Oh, I'm sorry, those are my best finds. They're not for sale."
Oh,
Said, "Oh, really? Oh, that's too bad." And she saw I was depressed. She says, "But follow me." She took me in the backyard, and she found this big, huge jar of broken artifacts. And she says, "Here, any of these you want, 50 cents a piece, you can have." And I was all excited. I went in this jar and I picked out the base of an arrowhead and the tip and the middle points, and all different colors. They made them from all different types of minerals and rocks. And so I took those home and I put them in my own case. One's only about this big. And that's it's one of my most valuable possessions, because from holding those artifacts, it caused me to wonder once again how these were formed and when they made them. And so what I started doing was doing the research, and I started pulling up what others had done. And I started going out, and I actually found areas. We had a cabin up in the hills, about an hour from where we lived, there in central Arizona, where it's just like this behind me. It's a lot of pine trees and stuff. And it turns out that unless you're by waterways, you're not going to find a lot of the arrowheads of the artifacts, because people have to have drink every day. You have to have water, especially in the summertime when it's hot. And they didn't have piping and, like we do modern day plumbing and stuff.
Yeah.
So you look for the waterways and where people lived around there. That's where the animals were and everything else too. So I started finding my own artifacts, and I had friends that had acreage that we could go on private property and do this. And what happened was I started researching world history, and I started researching, which is found in the Bible, by the way. And then I started researching my artifacts were real, and I knew this world history. I'd already confirmed many different ways that it was real. But over here, I was reading this research from various archaeologists, and it wasn't making any sense. They're talking about 10,000 or 20,000 years or 100,000 years, and I'm going, wait a minute, these people didn't live that long. World history shows that man's lived for 6,000 years. I didn't know at the time back then, but now we have DNA evidence that proves this conclusively. And this is all in volume 2, by the way, in the living model and in the evolution pseudo-theory model, and also the chronology chapter, which is called the age model. So in volume 2, we really get into the age of everything. And I found out that what these researchers were doing. I didn't fully understand. I'd already graduated from college. This was something that I thought the college professors would understand, but it turns out they didn't. So my story begins with this archaeology, and I went and I started doing this research. And after several years, all of a sudden, I found something that was very unique that no one to this day, until you read volume 2, and you have to read the Clovis model to find this answer. This was my very first discovery, and that was that nobody has been able to describe in North American archaeology where the Clovis people come from. These were people made an artifact that was very, very, this is the Clovis model, very, very unique in artifacts, as you can see there. And if you notice in this artifact, where I'm holding it there, there's this, we call this a flute. So this is a big chip going almost the full length of the artifact. Okay? This technology, how did they knock out this whole long flute, had not been known until 1966 when an amateur archaeologist figured it out.
Oh, wow.
It didn't come from the professionals. And what's really interesting here is that these artifacts are the only artifacts in the world that are found in direct association with fossils. We're talking mastodon, these are elephants, and bison, which are like a buffalo. Their bones turned into rock. The artifacts were found in conjunction with the bones. In other words, the arrow or spear point had killed the elephant. When this was first found in the 1930s, it was out of Clovis, New Mexico. That's why they're called the Clovis points.
Okay.
Scientists were like, whoa, what's this? They wanted to call these artifacts really old at first because, they're not with bones that are just back behind me. When a deer or an elk dies, what happens to its bones? When they all fall on the ground, they decay because there's bacteria in all the ground, and the animal decays and all his bones. After just a couple of years, they're all gone.
Yeah.
Okay. So how does the bone turn into a rock? Even if you go burying it with soil, all the soil has bacteria in it. It decays even faster if it's wet, especially under trees and everything, and it's moist. It's gone after a little while if it's buried. So no paleontologist, any guy that deals with fossils, has ever been able to explain how things turned into rocks. And I got 2 here. Here's an example. This is a bone, and that's the marrow in the middle point there. This is the polished end. You can see this part here. That's from the outside, it's kind of like a rock, but this is actually a bone. It's a fossil, and this is a dinosaur fossil. Okay, and a lot of people don't realize this is a quartz-based rock. Okay, so this one is kind of been polished on this end. You can see how it's kind of smooth and shiny there. Okay, and this is the red over here is actually inside of bones. You have the cells and everything in there. You can actually see these in some of them when I have cross cuts on them.
Wow.
This is an interesting point. By the way, remind me when I bring it up later, I'll talk about this is also in here. See this white stuff?
Yeah.
It's called the surface mark. We're going to talk about that. That's part of the flood. What is calcium carbonate? Why is there white stuff that's thick? You can't just scrape it off with your finger on one side of so many rocks all over the world. And it's right on the surface. Nobody's ever been able to explain that. No one's ever been able to explain how this bone turned into a rock. This is a quartz-based rock. So we're going to talk about that today, how those are made. And it's going to be directly connected to this rock. So this rock is a piece of petrified wood. This right in here is a cross-section.
Of a tree.
This is the wood, the brown part here. But look what's around it. Look at that. What is this white stuff? And what's that right there? That looks like a geode. And that's because it is, Tresta. That's a geode inside a rock that was wood. How did that happen?
Wow, that's beautiful.
We explain this. These type of rocks. This is from Wyoming. This piece of petrified wood from Wyoming is where I finally figured out how petrified wood is made. Because once you understand how this rock here is made, you understand how this rock in the middle was made. They're both rocks. They're both silicon dioxide. They're made out of quartz today. So we're going to explain in just a minute how quartz is made. And as we do that, we're going to learn how this petrified wood is made because we actually make it. So
Awesome.
that's an exciting.
Yay, that's awesome. So your first discovery was the Clovis people.
Yeah, so the Clovis people and understanding that the Clovis point is found directly with the bones of these animals that have turned into a rock.
Mm-hmm.
Nowhere else in the world you find this except for North America. So North America is the oldest. You open up your science book, they typically tell you Clovis people are 10,000 years old, but they're not. Okay. One of the most important things of the universal model is that we have a chapter called the Universal Flood. And in this book, it's the longest chapter in the book. It's 250 pages roughly. And that's a book in itself. Okay.
Yes.
And that chapter has hundreds of evidences, geological evidences that the flood was an actual real event. And we use in volume 2, we have a bunch of historical evidences and from other sciences, dendrochronology, which is tree ring dating, and other ones that we actually show the flood happened from a myriad of other evidences. But the fact that the flood was a real event that actually took place completely changes modern science. And this, I found this out, and this one professor I went to and to ask about these Clovis people, he wasn't getting my questions. I was asking really simple, basic questions. And this is why I got started on the and this all got started, and I left my studies with the real estate and everything, is because when I went in and went to ask him some very basic questions about archaeology, because you can't understand archaeology unless you truly understand geology.
Mm-hmm.
Why is that? Because in geology, there's layers, okay? It's called strata, and these artifacts are found in the layers. Unless you understand when they were laid down, you can't understand these people, when they lived and how they lived and all that. And so the geology and the archaeology are interrelated, and I was asking this professor the question about the flood, assuming that he believed in the flood. I mean, this is even a professor that belonged to a religious institution. I thought he'd believe in it. And right in the middle of when I was telling him this, I'll show you a picture here, beginning of that flood chapter, what he said. Because this is really important. And it caused me to realize, oh my word, these guys don't get it, that the flood was a real event. And this is when I first found out about this. Notice what he says here. Can you read that?
There will never be any scientific evidence for the universal flood. Wow.
So this was a guy that, was supposed to believe in the flood. He believed in the scriptures supposedly and everything.
Mm-hmm.
But the flood is a non-event. It's not real. It's a myth. It was just some guy talking about, some local little flood or something. Well, no, that's not what happened. Okay.
Yeah.
Noah was either a prophet or he was not. And the entire world died. Everybody was killed except for 6 souls, and that were his 3 children and their 3 wives, and then the mom and dad. So 8 people total that were on that ark. We all came from them. And this is in volume 2. We showed genealogy-wise, family history-wise, that this really was happened. But back to the archaeology stuff and the geology. So this professor just floored me when he told me there'll never be any scientific evidence for this. What it led to was understanding that these first people that lived on the earth, we didn't come from an ape out of Africa. These were the Adamite people. These from Adam and Eve and all their family, okay? They actually started here in America. And we have for the first time physical evidence demonstrating this. That's why these bones, they got made this way in the flood. See, this is where the proper pressure and temperature, which we're going to explain here in just a minute, how rocks are made. Once you understand how rocks are made, now you understand how these fossils, which are rocks, they're quartz-based, are made. And once I found this out and realized that, oh my word, it just changed everything. And this is how I came to understand that modern science in general is completely following the false theories and philosophies of men that make no sense. This is why everything comes from nothing, right? That's the big picture of modern science. How does everything come from nothing?
Yeah.
Tresta.
There's nothing
we all
there.
know that. Something doesn't come from nothing. But this is what you'll learn if you go take classes and all the sciences today.
Yeah.
So that's what the universal model is for, is to refute this and to show you for the first time a real scientific method. By the way, we start with theory and we end with natural law in our scientific method. And we've used this method in all the fields of science and made new discoveries, hundreds of them, dozens of new natural laws, not one or two, dozens of new natural laws in all the fields of science.
Well, I would like to bring in my daughter to ask you the next question, if you don't mind.
Great.
Okay. All right, Talia, come on in.
This is Italia.
This is Italia, yep.
Hi, Italia. How are you today?
I'm good. Is the Earth a hydro planet? If so, where does lava come from?
Great question. So what she's asking here is, this is what we're all taught in school normally, okay? It's called the magma pseudo-theory. And the inside of the Earth is full of this hot, molten rock, okay? It's called magma. By the way, a pseudo-theory is a false theory taught as fact. We've all been taught that all of our lives, and the universal model demonstrates it's not correct. That's right. We don't have this hot molten magma inside the center of the Earth. Let's talk real quick why that's the case. We have a whole chapter that goes into a lot of detail on this, but let me just grab a rock here. Okay, this particular rock is, you can see it's black. Okay, it's called basalt, and so this is a rock that over in Europe they build for several thousand years. They built cobblestone streets out of this. It's a very, very hard rock. They can drive and ride on it and so forth, and it doesn't break, and that's because it's quartz based. Most rocks on the crust of the Earth are made out of quartz. This is very important to understand. Quartz, by the way, is a clear crystal, kind of like this. This is a quartz clear crystal, okay? But when you mix other iron and magnesium in with it, it turns black like this one is here. Now, every geology textbook you open up is going to tell you that this rock is the most abundant volcanic rock in the world. So volcano, what does that mean, Italia? It came out of a volcano, right? If it's volcanic. If this came out of a volcano and it's volcanic, then why, when I take an acetylene torch, so that's a gas torch with oxygen, and I actually melt it, notice that end of it there.
Yeah.
Why in the world does it look like that? If this whole thing came out of lava and was melted, why, when I actually melt it, it gets red hot and I melt it, does it look like that?
Because it's not from lava?
Exactly. You got an A for today, because it didn't come from lava. If it would have come from lava, it would have been this. You know what this is? I have some over here. Usually if I put these on, they're glasses, right? When you take quartz, clear quartz like this, and they do this with sand, and they melt it all down, it turns to glass, which your windows are made out of. It's glass. Now, that's what this is, but it just has some other elements in it, like iron and magnesium, so it makes it black. But the point is, if I tap this on the table here, I can break it just by tapping it very easily. Okay, glass, you know, when you drop a pane of glass or my glasses, I can break them really easy because glass is breakable. But this original rock here is very hard. It's not. Now this is critical because glass is something that is not understood in science clearly. They don't, the modern geologists, they don't do this. They don't melt rocks in their classrooms. I found nobody that has been melting these rocks in the classrooms. This is really, really important because if you want to say that rocks come from a melt, remember, the whole Earth is a sphere. Okay, Talia, why do you think the Earth is a sphere? You ever wondered why is it a ball out in space? Okay, the reason it is you can't have other rocks hitting other rocks and make a perfectly round sphere. It just doesn't happen. Out in space, just like when you blow up a beach ball and it goes into a circle, right? Out in space, you have to have a liquid for it, or a gas, for it all to be in a spherical shape. Okay, so we know the Earth was not solid when it was formed, because if it would have been all different directions. When you have enough material, the gravitation all pulls it to the center and it makes it into a spherical shape. The scientists know this when they go up to the space station. They squeeze water out of a bag. It'll float in front of them because they're in microgravity. It'll float. Water will float in front of them in a ball.
Mm-hmm.
Okay. And so this is actually where the earth comes from, is it comes out of this water. The earth was a spherical hydroplanet. I'll just say amazingly, because it just gets me every time I show people this. We have a whole chapter in the book called the hydroplanet model. And if you go to that chapter, at the very beginning of it, we talk about celestial water. And here we go, celestial water. So here's one of the picture I was just talking about. And you can see the planets around. There's scientists blowing the water. And like we asked the question there, if there's no magma, if we don't have magma in space, nobody's ever observed inside the earth magma, by the way. We have to question everything with an open mind. That's the first principle of the okay? If nobody's ever seen magma, a planet that's all melted, well, then why would we think one exists? Because it doesn't. There's actually moons around Saturn and Jupiter right now, which are all made of, guess what? Water. So even this, Saturn, we all know it has rings on it, right? Can you read that? What's that say? NASA, what did NASA say about Saturn's rings?
Saturn's rings are made primarily of water and ice. Wow.
Looky there. You won't learn that in your typical astronomy class. Let me show you another one. So read this quote. So this is a moon, Tethys, and it's a hydrosphere. So this is a moon of Saturn. Okay. This is also NASA. What does it say about this moon of Saturn?
This moon is known to have a density very close to that of water, indicating it is likely composed mainly of water and ice.
So as you go through here, you're going to find out an amazing thing that's not taught in your typical astronomy class today, and that is that every single planet and every single moon, they found water on it. And some of them are made, just like you just read, primarily out of water and ice. So going back to our situation, they don't have evidence for this magma inside the earth. Okay, the melted rock doesn't exist. See, here's the problem though. All of the rocks are supposed to come from what they call the rock cycle, which is show you a little picture of that here. On the bottom of the rock cycle, we have metamorphic rock, we have igneous rock, and sedimentary rock, okay? And on the very bottom of this little cycle, Talia, what's that say down there on the bottom?
Magma.
Magma, exactly, okay? So do you see how everything goes around in a circle? There's igneous rocks, the metamorphic, sedimentary, and then it's all based on coming out of magma. Well, magma is a molten rock. They're saying the whole earth was molten. The problem is that when you melt quartz-based rocks, guess what they all turn to? Glass.
Yeah. We
just showed you that, right? Here's another piece here. So here's a piece of sandstone. And at the top here is this is a mineral called hematite. It's made out of mostly iron, okay? And what I did is I took my torch again, went on the top, and I melted it. And as you can see, this little area up here is totally different than all the other rock around it, okay? That's melted sandstone. This is a piece of sandstone, which is quartz-based, even though the hematite is the primary thing here. And this is an amazing thing to show you, if these rocks were all really from a melt, they would look like this.
Yeah.
Be glassy. I could break this off if I try really hard, just with my fingers. You have to be real careful with this, okay?
You must have had fun with a blowtorch, huh?
Yeah, I do that a lot. I melt all kinds of rocks. It's a lot of fun. Because they don't do this in school. And they teach the kids rocks come from a melt, but they never melt it. They don't show us, because then the kids are going to ask questions. Well, wait a minute. How come all the rocks I pick up on the ground don't look like this? They're not glassy. They're not made out of melt. There is real lava flow. Okay, we got to mention this real quick. So there are real lavas. In Hawaii, there's been a lot of lava coming out over there in the news this year.
Yeah.
Okay, so if there's no magma and there's no plumes coming from the center of the earth and coming up and coming out and making this lava flows, because who's ever observed magma, Tresta?
Nobody.
Nobody. Okay, so this is it's a big red flag. We need to ask a question. If nobody's observed magma, okay, how do we know it exists? Well, we don't if no one's ever seen it. Science is about real observable things. But we can observe lava, right? I don't know if you ever have, but I've been to Hawaii. I've seen these lava flows, okay? They're very real, okay? They don't happen everywhere all the time. Matter of fact, they happen at very specific times and in specific places. And what you find is we demonstrate in the book, one researcher went and found 600 different instances of lava flows. And guess what they found before every single lava flow? Earthquake. So I'm going to show you something here real quick. I'm going to do an experiment here real quick. See if we can do this online. Look at my hands. You can kind of see they're pretty clean, right? Okay. Well, I'm actually going to make some skin lava right in front of your eyes. You're watching this, right? I'm getting about 150 degrees and 150 pounds of pressure. And guess what I just created? Oh, it fell down. Wow, it all fell down here. It's all on the ground. I'm going to pick this up. Okay, let you see it here. See that? There you go. You can see it.
Oh, yep.
That is skin lava. Look at that. That's my skin. Okay. That's my skin. And that was only with 150 pounds. Now, if I do 1,000,000 pounds of pressure in a fault line, because it has all that weight on top of it, right? And 1 centimeter of movement, researchers have found tens of thousands of degrees created with the friction in the fault line. And you only need 2,400 degrees to melt rock. So guess what happens? When you start having these, and they're actually called silent earthquakes. Most lava doesn't come from a big, huge movement, because that was just real quick one time. It's over several days of small movements. And these silent earthquakes are ones that are down typically below 2 on the Richter scale, so you can't feel them. You can definitely feel 4 or 5 or 6 or 7. But the real small ones you can't feel. However, they're very real. They just happen smaller time. And because of all that pressure and temperature, remember, it gets real hot when I rub my hands, right? Okay. That's where the rock melts in the fault line. When it melts, it expands. It has to go somewhere. So guess where it goes? Where the least pressure is, and that's up the crack and out the volcano. So that's where lava comes from. It's really simple. It's simply friction, okay, between the rocks, between the fault lines. And we demonstrate this with numerous reports and stuff. Now, another evidence that rocks, and by the way, if you ever get a lava rock, like a piece of pumice, I have some here in our rock kit. We have all these, there's like 27 different rocks in here. And these are lava rocks. And some of these even float on water because they have in them air pockets and stuff, and they're very light, okay? If you take this and put it under a microscope, guess what it looks like? Little glass shards. Scrape it off into a microscope and look at it, it's glass, and it has a little coloring in it. That's why those look red. But they're glass, it's melted quartz, okay? So that's where lava really comes from, is from this movement, okay? And earthquakes, by the way, happen on regular intervals throughout the year. They happen like in the fall and springtime more often. And because of those time frames, they have the lava flows more often during those times. And so there's lots of cycles in nature that explain this, and we have lots of additional evidences showing where lava comes from. But here's another thing that's really neat. I don't know if I didn't bring with me, but I will just mention it. In our kit here, we have 2 rocks. It's kind of light out here. Probably not going to be able to see it, although you might be able to if I do it up here. I don't know. Let's see. Here. I don't know if you can see this. So what I'm trying to do is create a spark. Indoors, I can turn the light off and show you real quick. But I have another little thing here. So that quartz, when you crush it up, it'll actually make electricity. We're going to see if this will work or not. I'm going to say this is a light bulb. Okay, 2 wires on there. And this is a piece of plastic, and in between the plastic is crushed quartz. So I'm just going to move this quartz. I'm going to hit it. Can you see? Did you see it light up?
Yeah. Yep.
Yeah.
There you go. See the light coming off it now, right?
Mm-hmm.
There, I hit it right in the middle. The light bulb comes on. So we're actually creating electricity with moving this quartz. And it's the same thing that happens when I had those two rocks. These are quartzite rocks. And if I was in a dark room and did it, you could really see the spark. They actually create a light and it's electricity. This is something technologists have used for a couple decades now. You and I are talking. I'm on a computer, and this computer has a little speaker on it. And the speaker and both the microphone use this piezoelectricity. This is called piezoelectricity. It's made from quartz. So what's important here is at 573 degrees, if I take this rock and I heat it to this, it's called a Curie point. If I heat that rock up to that amount, it's way below melting it. You need 1700 degrees Celsius to melt this. So it's a third of the temperature. And guess what happens to the piezoelectricity of the rock? It goes away.
Mm-hmm.
It's gone. So rocks would lose their ability to make electricity if they've been melted. So this is a whole nother evidence proving that all the rocks didn't come from a melt, that the earth wasn't all melted from because we wouldn't have piezoelectricity rocks all over the surface of the earth that are quartz based.
So the electricity doesn't go away, right? Because matter is never created nor destroyed. So does electricity just go?
Well, you can't create the electricity because when you melt quartz is in a crystalline form here, okay?
Right.
When you melt it, it turns to glass, and glass is when it cools very quickly, it's called amorphous. It's not in a crystalline structure like this anymore. Okay. And it goes away, and it's very brittle. Matter of fact, they both have SiO2. That's silicon dioxide. That's the chemical formula. Is the same for glass and quartz, but they're very, very different. And so let's talk about how rocks are really made. They don't come from a melt. Okay, we all know what glass looks like, right? It doesn't look anything like that quartz crystal.
Did you want to talk about the flood before you talked about rocks?
Let's talk about rocks, because the flood, we're going to be able to understand the rocks, and we understand first how rocks are made. So this is the hydroplanet model, right?
Okay, yeah.
And we'll talk about that with her question. Rocks don't come from a melt. Okay, so we're going to show you, I'm going to show you right now here an example of the Earth. Okay, the Earth is actually a big geode, and that's what this is. This is a polished geode from Brazil. Okay, and hopefully you'll be able to see this here. Oh, let's put this down here. Let's see if I come up here. There we go. Oh, maybe if I go right up here.
Yeah, we see it. It's moving water. That's awesome.
Can you see that? So I also have, I can do here on my phone, I put a little bit of light behind it. I get too much there. Can you see it now?
Oh, yeah.
Yeah, quite a bit.
Okay, so the inside of this rock, about half of it is water and air. That bubble is air, okay? And you can see all the water moving around down in there.
Mm-hmm.
Okay, and you can see there's actually some crystals. See that right at the top there? You can see that inside there. If you open this up inside, it would look something like this. So before it was made, okay, this is the outside, just looked like a rock on the ground, right?
Uh-huh. Wow.
When you open up, see all these crystals inside here? That's what you just saw when you polish the whole outside of this. It would look like that other one, okay? I just showed you here. And this all inside was full of water when it was made. That's why these crystals are sharp and pointy like that, is because they grew out of water and they had room to grow into, okay? So these geodes, which is very common, we all know about geodes, but what they don't teach us in school, they don't realize, is that these geodes are formed out of water. That's why you can see this one in here. Okay, you can see my bubbles that are moving. Okay.
Mm-hmm.
Oh, there we go.
Yep, sure enough.
Yeah, look at all that water. You see it all moving in there?
Yeah.
So this has a whole bunch in it. There's more water in this rock than there is rock.
Yeah.
Isn't that amazing? So this is full of
23.
this is full of water. And so both this geode and this geode are polished ones, okay? And they're sealed, so the water stayed inside them. They're called anhydros. Now, when you cut one of these opens, a lot of time the water will come right out of it because it has that in it. You can see there's some amethyst inside there, purple. See how pretty that one is? It's been polished here on the front. But this all had water in the inside of it when it was made. Now, this shouldn't be a big surprise. Here, this other one that I was showing you is a quartz crystal. Okay, let's see if we can see right here. Okay, here it goes. So look at this face right here. And let's see if I can. Okay, I'm going to turn it down like this here some more. Okay, if I don't look at the screen, I can do. Can you see that now, right here, going back and forth?
Yeah, a little tiny bit.
Yeah, I see it.
Oh, that's the bubble inside here. See, this is a water bubble, all going back and forth there. There.
Wow, very cool.
Okay, well, I have one that's really easy to see. And that's this guy. Okay, so this is a pretty big one. So you can see how big this is. Okay, this is a really nice one. So look right here.
Yeah, I can see that a lot.
Yeah, the big air bubble. Oh my gosh. That's
Bubble. Isn't that not amazing?
Yeah, that is amazing.
Okay, so how did all that water get in there? Well, it's really simple. This quartz crystal grew out of water. Now, how do we know that? Well, I'm going to show you how we learned how to grow our own crystals. And we're not talking crystals that are really, you can find rock crystal kits online, go to Amazon, you can find them. And they typically, when you have water, we can all do this in your kitchen. We take a glass of water, put some salt in it, and let it eventually dissolve, stir it up right. And then when you let the water evaporate, you'll actually see crystals grow inside the cup, right? We're all used to that.
Yeah.
But salt isn't that hard. It's not like quartz, which is on a scale 0 to 1 to 10. It's on a 7 on the Mohs scale. Okay, so it's pretty darn hard. But the quartz grows the same way out of water. But there's one big difference. Most of the rocks that you pick up on the ground, they're quartz-based type rocks. They all grew under pressure. So this is a picture of how we learned to grow quartz. So what we have here is, this is an oven we made, and this is a high pressure pipe called an autoclave, okay? And so this pipe is put down inside the oven. It stood straight up and down there. It's about a yard long, a meter high. And at the bottom of the oven, we heated it about 400 degrees and the top about 350 degrees Celsius.
That's
so the
awesome.
difference in heat, what does heat do? What does a fire smoke do? It rises, right?
Rises.
Okay. And when it cools down, it comes back down. Do you know what that's called? When heat rises and it comes down, it's called convection.
Oh.
Okay, so you learn this in physics. It's called convection currents. Hot rises and then the cold comes down. So inside this pipe, what happens is down the bottom, we put quartz in there and it gets dissolved in the solution. This is in water. And it's 14,000 PSI pressure. Now, you and I right now are under 14 pounds. That's all the air above us. Creates about 14.7 pounds atmospheric pressure, they call it. You know, your tires in your car are typically like 60 pounds pressure, okay? Well, imagine being under 14,000 pounds of pressure. How would you get that? Well, it's 5 miles of water.
Oh.
That's the same height that the water covered all the mountains around the earth.
Yeah, that's
That was
awesome.
during the flood. That's how much pressure we had. So
Wow.
the temperature, by the way, this 350 degrees exists right now in the bottom of the ocean, under several miles of water. Rocks like this are being formed, just like I'm going to show you right now. I'll
Awesome.
show you a picture of that in a second.
Okay.
So what we
I
did
have
is
Natalia has to go right now, so I'm going to bring in Tieka real quick.
Oh, okay, great. It was good seeing you again. Talia,
Thank you.
bye-bye. So TKL, right?
Yep, Tieka's coming up.
Okay, Tieka. So what I'm going to show you here is this is a quartz crystal with wire wrapped around it. Okay, and we put it on this little, this is a hanger, crystal hanger here. So it was at the very top of it, inside our pipe there. Okay, so with this little guy in there at the very top, what happened is that when the solution got hot on the bottom inside the oven, it rose to the top and it got cool. And when it got cooled, it wants to crystallize out of solution. Okay, and when it crystallized out of solution, this little rock right here grew into this rock. And how long did it take? What's it say?
After growing, double in size in one day. In one day. Wow.
What do you think about that? One day, we were able to double the rock size.
That is incredible.
Okay.
Wow.
So here when you have rocks, salt, you just put it in the water, it dissolves by itself. Well, it turns out every rock that you could pick up outside and give me, I could put it inside this reactor, and guess what? It dissolves. Every rock. You just have to do the right pressure and the right temperature. So once you get all rocks being able to dissolve like that, all you have to do now is have a little cooler area, and when they come to that cool area, they'll crystallize out as all the rocks we find on the ground right now. That's why
from every direction, right? They go from every direction.
Yeah. See, so this was a crystal that was growing this way. Yeah, they all have their shapes and sizes, and this is the one that has the water in it. But you can see it there, and so this is why there's water inside these rocks, is because they grew out of water, and this was the water that was trapped in it.
Yeah, that's awesome.
Okay, so this is real important in understanding. I do have one other rock that actually has, this was done in the flood too. I'll have to see if you can see this one, because there's some dark stuff in it. Let's see if I hold it up like this with a white background, you might be able to see it.
Oh, yeah.
Okay, so right here, there's a big bubble right along here. Now, what's interesting about this is I go to turn it around. You look real close, you're going to see some of that black stuff all down here.
And you're mixing, yeah.
I can get it to. Oh, there it is, right there. It just fell down. Let me go back up this way. The black stuff will fall. Watch the black there on the top. There it goes.
Oh, so what is that?
Right here. So this is like coal. Watch it again. It's going to fall right there. This is right here.
Yeah.
Okay.
So it's like a rock, or it's acting, it's like it's slow.
Yes, because it's in water. Okay, see, there it goes. There it's falling. See, right, tap it. So there, this has a bubble inside it too.
Yeah.
You can't see it very well the way the lighting is right now, but this has a big bubble in it. And then it has all this black, it's like a coal-like substance, and it will fall down inside the bubble in there. So the coal was leaves and things biologically that were in the floodwaters.
Oh, okay.
And see, researchers can go in and they check these bubbles that are inside here, and they can go in and this is all documented in the Universal Flood chapter. And what they do is they're able to pull out, they go in, they drill into that in a vacuum, and they can tell what pressure it was made under. So they're able to tell the temperature and the pressure this rock grew in.
Wow.
And they all match exactly what we were talking about, how rocks are made out of water under pressure.
Awesome.
So these are, confirmation after confirmation showing how these rocks are made, when they were made, The flood actually happened 4,363 years ago. We actually, in volume 2, have evidences showing the time of year that it actually happened. It was springtime.
Really?
Yeah.
And
So
we
let's
know
look
that
at,
by.
here's a pine cone, right?
Okay, yeah.
Okay. Tikea. Am I saying your name right?
Yeka.
Tieka. So this is an open pine cone, meaning that the seeds have all popped out. Okay.
Yeah.
What's interesting about this is after the springtime, because when they first form, they're still green and they're all closed up, right?
Mhm.
But then after the springtime comes, especially if there's a fire, they open and pop open and all the seeds come out, and that's how they, grow another pine tree. But isn't it interesting that all the fossil pine cones you find, like this one here, okay, they're not open. They're all closed.
Yeah.
So see, if these have been forming over millions of years, then you would find some open, some closed, all different kinds and different stages, and we don't find them. They're all made because they were turned to a rock. This is a rock. It's heavy now. It's quartz.
Yeah.
This was turned into a rock very quickly in just days only. And it happened one time of the year, and it was springtime. This is when the flood took place. It actually correlates back to in Genesis 7, it talks about February 17th, but you have to convert that from the Jewish calendar, which is a lunar calendar, to our Gregorian calendar. Right now we use the sun. And when you convert that over, that happens either at the end of March or beginning of April, which is springtime here in the Northern Hemisphere. So this is real important because this is when, just like the recorded history tells us, okay, in the Bible, when the flood took place, we actually have not just pine cones, but there's a whole ton of fossils. For example, reptiles. When do reptiles have their eggs? Okay, whether you're going to be like a snake, okay, or different type of reptiles like that, they have them during the springtime. And guess when they actually find clusters. In China, there's some areas that they go digging around, and there's literally thousands of these clusters of eggs, and they're dinosaur eggs. And they found them, and they're all turned into rocks. They're all rocks in their little nests, and they all got covered with sediment and preserved under the pressure and temperature and turned into quartz-based rocks.
Wow.
All dinosaur eggs. I didn't bring mine with me, but I usually have one that I show on the inside of the dinosaur egg, and it's all turned into quartz. So you can see the shell on the outside of it, on the shell.
Yeah.
On the inside, it's all turned into a pretty quartz, kind of like, here's just a pretty quartz rock there. That's an agate. Okay, but this is all quartz based, and that's kind of what the inside of my egg is. I have at home.
That's cool.
I have in volume 2, we made another special discovery. The very first preserved, and this is in amber. Okay, now amber, scientists want to think is millions of years old. It is not. It's only 4,363 years ago when the flood happened. By the way you can remember that number very easily,
Yeah.
the flood happened in 2345 BC. 2345 BC.
Huh.
And you add today's date, 2018, to 2345, you get 4,363.
Awesome.
So that's how I remember the date.
Thank you.
2345 BC is when the flood took place. And we actually have general chronology demonstrating this, okay? So various, not just with rocks, we have various other forms of science and even genealogy and historical records, all going back showing that we're all related and connected to Noah, by the way, and his children. And this DNA demonstrates this also. So, I wanted to mention our other discovery that we made out of amber, and that was with, and by the way, I'll tell you the story real quick. I can't tell you how I found it because I don't have enough time today, but the story was really neat how we found it. And this piece of amber, I do have a picture in here, so I'll look here to find it while I'm telling you about it. It's very, very unique. It's the very first piece of amber ever found that has both fish eggs and frog eggs.
Oh, wow.
Now think about that for a moment.
So somehow they got mixed.
Well, amber is, I have pine trees behind me right now. See a pine tree? And you'll see the sap coming off it. Well, that sap, if it's preserved under pressure and temperature in a hypertherm, by the way, we call this a hypertherm. Those conditions that we made, those quartz rocks, the quartz rocks, okay, inside that autoclave, okay, that is it's called a hypertherm. There's not even a word in chemistry or physics that describes hydrothermal is heated water.
Yeah.
Okay, but we're talking about heated water under pressure. That there is not a term in science, in modern science anyway, that describes heated water under pressure. So we created from hydro, the high, that's the water, pre from pressure, and thermal means heat. So hypertherm is the conditions you have to grow this rock.
Cool.
Okay, and so I have lots of man-made rocks like that that have been grown in a hypertherm, and it's very, very important to show us how that's all done. Okay, so I'm looking right now for my, here we go, I think it's close here. Okay, so here it is. So this is a picture of this. And I'll tell you the story while I'm holding this up and you can be looking at it. Okay.
Okay.
So you notice there's, see different pictures there?
Yep. Different eggs.
Okay. So it turns out, by the way, you can look in here. I said you got it really up close, you could see. These are the fish eggs, these guys here. And right there, you can see in the picture, there is a little bubble in that one. There's about half of the fish eggs you can actually see in the photo, a bubble. That's an anhydro. That bubble moves around in water inside that egg.
Wow.
Now these are the frog eggs right here. And it's coiled up, but it was flat. This is how frog eggs are today, like this. And these are real fish eggs today. Okay. So you can see in here, here's some more pictures in there, and you can see here we go, up close. Oh, you can see the anhydro bubble right there. See that little bubble, the arrow's pointing to it?
Yep.
Right there, yeah. So that's a bubble inside, and it moves around inside the egg.
Wow.
I saw this and I was like, most people would not recognize this. I actually have a pond in my backyard. It's called a koi pond, which is a Japanese carp. And so I raised fish since 2005. I'd had this pond. And for several years they spawned, meaning they had eggs and then, the babies and stuff. And so I took out a bunch of the eggs and put them in containers and aerated it, and actually the carp, which are called koi, the fish grew, and I actually, grew a bunch of them and sold them and everything because I couldn't keep them all in my pond. It made thousands and thousands of eggs, right?
Yeah.
So, but by going through this process, I actually, in volume 2, you'll actually see, we talk about the pond because our world is a pond, and how everything is so natural. And the word that's important for the kids to learn is symbiotic. A symbiotic environment is where the plants and animals all work together to exist. Okay, they're harmonious, and it's very important. The plants in my pond, they use the nitrates. These are the waste products from the fish. When they have waste products come from them, the plants use them for their growing, and then of course the fish can eat the plants.
Yeah.
So the nice thing about this is that because I was around these fish, I learned what these fish eggs look like. Because most of us don't see fish eggs every day, right?
Right.
Around fish and doing that a lot. So this caused me to know what these looked like, and it turned out that when I saw this piece of amber, the people that were selling it had no idea what it was. And as soon as I saw it, and then I saw these little bubbles moving inside it, I recognized, those are anhydros inside a fish egg, and it's moving. I was just like, I don't believe this, because I've already written a whole subchapter on amber, and amber people have no idea how it's made. We actually demonstrate in the book how amber is made, because it has to be in this hypertherm under the pressure and temperature and water, right? Because your sap, by the way, on my tree that's behind me, when that sap comes out of the tree, in one day, guess what happens to the sap? It gets a layer around it, and the layer turns hard. In a couple days, you can't even push your finger in it anymore.
Yeah.
And after a couple of weeks, it'll get really hard. It'll fall off the tree down on the ground, and it deteriorates and goes away. A couple of weeks.
Wow.
So how do you get chunks of amber? They have some chunks of amber as big as I am, way more than I do, that they have found in the ground. And it's tree sap, and it's still there. And you break a piece open, it's all perfectly smooth inside like glass. It's been preserved. And there's insects all throughout it. And amber, the sap on a tree, they use it to take away the insects, like the beetles and the ants and everything that can harm a tree. It's like an insecticide. It kills them. That's why the sap is there. So why I have a piece
That's interesting.
That has almost 1,000 termites in it. Where do they come from? Termites, the last thing they want to be is near amber. It would kill them. And they're all preserved inside. And guess what else they have? Little wings.
Wow.
And those wings on termites normally don't have wings except for one time of the year. Springtime. And they all swarm because there's a flood coming in. They all swarm and fly away and land in a dry area. That's when termites get these wings. So you have to understand there's no explanation in modern science how termites could get into amber. And of course, we have the explanation there because we know about the flood. Because what happened is when the flood happened, all these trees got knocked over. A lot of them would float, and they were up on top. When all the water's covered everything, there's no more land. And remember, the bugs, there's millions and millions of them. Mm-hmm. They're swarming around trying to find a place to land, and there's nowhere in their vicinity to land. It's dry.
Yeah.
What do they land on? Something that's floating. Well, that's the wood. And coming out of the wood, by the way, when you have the most sap that you have coming out of the tree is during rainy seasons. Now, during a rainy season, when there's a lot of water and the roots bring all this water up and they get all this sap in there and it starts goozing out, okay?
Yeah. These
floating logs were in water and they were goozing all this amber, tree sap. When the animals came and fly, that was the only area to land was on this floating stuff. And then that's why there was both fish eggs that were in the water and these frog eggs were in the debris and they got stuck in the amber. So anyway, I ended up showing these pictures to the collectors that collect amber. And I asked them, have you ever seen this before? And the one collector, and I got this all documented in the book through emails. It's all written in there and you can read it, his story. He goes, Dean, the likelihood that you would have found amber with fish eggs and frogs eggs in it. Remember, amber comes from trees in a forest.
Yeah.
We're talking amphibians and fish out of water, right?
Yeah, totally.
The likelihood you would have found fish and frog eggs in amber is the same as me walking outside of my house and blue ice falling off a plane and hitting me. It's like, It's not going to happen. It's not real. So I ended up sending these photos to University of Colorado, and we have fish experts there, some of the best in the world, and also amphibian experts. And they looked at these, and both of them said, one guy was a frog guy, and he goes, I think I know what kind of frogs these are. And he started telling me about the frogs and everything and where they're from. He even says Central America, which is where the amber is from.
Oh, wow.
The fish guy started describing the fish and everything and all that. There wasn't even a question in their mind that these were fish and frog eggs. So I'm going to do DNA testing on it and find out the exact species and stuff of them. Just haven't gotten around to it. But that's a pretty fascinating discovery that we made that no one else in the world has made.
Wow.
That's pretty exciting.
How many proofs show that the flood happened?
Well, that's a good question. So when we talk about proofs, and this is really what science is about, is evidence, right? Physical evidence we can all observe and see. That particular chapter in the book called the Universal Flood chapter, there's 13 marks of the flood. And every one of these marks is a mark that is so unequivocal. I'm going to show you one right now. It's called the surface mark. It's one of my favorites. Okay, so the surface mark is about on the surface of the ground, and these are mostly out in deserts today. So in the book, I have in Arizona, for example, I've gone to the deserts. In this rock kit here, we have some of these. I'm going to talk real quick about surface chalcedony. And so these are some that I actually found in Arizona, and you can see that one right there. This is a chalcedony is kind of a rock. It's smooth. You can kind of see there. See how it's smooth on one end, but on the bottom, it's flat and it's kind of rough. That's because it grew on the surface, and that rough part was on the ground. Here's another one you can see. One side is on the ground and the other side is smoother. But I have some from Peru that are really big and pretty and nice. As you can see, this one here, that's the bottom. It was on the ground. And then look at the top. See how it's all smooth?
Wow.
Pretty up here. It's crystals even in here.
Yeah.
And here's even another better example one. This is the bottom. Okay, that was on the ground. But look at the top of this.
Wow.
Isn't that amazing?
That is amazing.
Okay. So this is called surface chalcedony. These are quartz-based rocks, and they literally grew right on the surface. Like I'm up here in the mountains, but in some mountain areas you can find these. I found them in Arizona in some of the mountains. And it's an area though that the ground has not changed since the flood happened, and you'll find them most of the time with this stuff right on the ground, still like this, so they're still buried in the soil. And this is the part that's exposed. It's been there for 4,363 years.
Wow.
And the discovery of this is amazing. These surface marks, the surface chalcedony is just one of them, okay?
Yeah.
I'm going to show you right now where the surface chalcedony is being made. Here's a picture in the book. So this is page 648 in the book. And you can see there's the top and bottom of each of these. These are ones from Peru.
Yeah.
I was just showing you there.
Awesome.
And here's one that when it's growing on a rock, you can see how those grew right on a rock. These are beautifully grown rocks. Oh, and this is in Arizona. These are all ones I found in Arizona out in the desert. You can see I took pictures of them before I picked them up right there on the ground.
Yeah.
Okay. So I have a picture in here, though, that's really important. And that's this one. This is called Tag Mound. Now, if you look on here, you can see in this photograph, this is actually under several miles of water on the bottom of the ocean. Okay? And what we have is it's on a fault line. We've already explained by rubbing the hands where lava comes from, right?
Yeah.
Lava, of course, heats up. Most of the fault lines contain water, by the way. And when you heat that water up underneath the ocean, it comes out, and this is called a hot smoker. See that smoke there? That one's black. Okay, some of them are white, some of them are black. And by the way, this is demonstrating how all the minerals in nature are naturally made, because here's pyrite. We can talk about this a little bit later, but this is a piece of pyrite. That's a pyrite cube that was made in nature, just like that. I have another one. Here you can see this is same thing, pyrite cubes.
Yeah.
But they're formed on calcium carbonate. This is made out of algae, out of the ocean water. Isn't that just neat?
Yeah, that is really cool.
Just like that, okay? Those are from that they found over there in a mine, right on near the surface, by the way. What's important is down inside here, there's pyrite they found. By the way, there was a ship that was over this mound, cost millions of dollars because they had to drill down through all the water. Well, they didn't really drill through the water, but they put their pipe down there. They went in the mound and they drilled down into this. And so they drilled in different spots and were able to get this cross cut. So this is actually out of a journal article, this diagram was, and I took and colored it all and added, the words and everything so you can understand it. So you see over here basalt, there's quartz and hydrite, that's a salt, okay? All the salt and the quartz rocks and the pyrite, like I just showed you, all made out of the flood. And what's coming out of here, the reason this is a black smoker is it's from microbes. Very, very important. I just showed you some rocks here like this color. When you see these colors in rocks, where do those colors come from? They typically think, oh, well, it's just minerals. Well, where did the mineral come from? Well, these minerals come from microbes. And the iron microbes are mostly the red ones, are iron microbes. And this is really, really important. So what you're seeing here is this is hot water, and I think it's 338 degrees C. Right in here, you can kind of see I have the number in there. That's what they're saying was coming out of this. So this is the same temperature, pretty close to what we had in our autoclave. See? So this is the same conditions inside that pipe under pressure that I showed you a little earlier. We made rocks. This is the same conditions in nature right now forming rocks, bottom of the ocean. And so this is really important. Now, the reason I'm bringing all this up, there's a fault line, the heated water was coming out, it's under the water pressure, okay? So the dissolved silica is coming out of this. When the dissolved silica comes out and now it's in colder water, guess what it wants to do? It wants to crystallize. So it lands down on the rock, on the surrounding area here, and guess what they found right on the surface? Can you read that right there?
Chalcedony.
Chalcedony. That's what this is.
Wow. So on the bottom of the ocean.
Same thing that was growing there in the bottom of the ocean is found in the deserts all over the world.
Yeah.
Right now. So those deserts are evidence, direct evidence that the flood happened only a couple thousand years ago. It hasn't been millions of years because the deserts would have all been changed.
Yeah.
They're on the ground, and most of them haven't even been turned over. See, there's the bottom. See how different it is?
Yeah.
Now it's crystalline because this grew up towards the water. Where that was down on the bottom there, and it can't grow in a crystal form.
So it has to grow in water. You can't grow that out of water.
No, it's all out of water. That's right, in the flood. Exactly. So this is very, very important. This is direct evidence that these formed on the bottom of the ocean, just like we're showing you here. Because these are found in the deserts all around the world. Only on the surface, by the way. That's why we call it surface mark. By the way, this is how I figured out how to make the petrified wood, because see this white stuff there? Yeah. That's the chalcedony. That's the same thing that we're seeing forming here on top of here is this white. Okay, this is chalcedony also. This is quartz chalcedony.
Yeah.
Same thing. So this whole thing had to be made in the same situation that this was made in, because they're the same rock. They're formed the same way. That is amazing.
That is amazing.
Evidence of how all the rocks got made, of how the flood happened. All these things are interconnected. By the way, if you look here, here's geodes. We're showing how geodes got made. Under the surface mark, we got a lot of other things. Geode is another one of the evidences of the surface mark. By the way, here's the dinosaur bone. This is the marrow in the middle of it there. And the same with this pretty agate over here was the marrow. I didn't explain, but inside my autoclave, one of the important ingredients is air. You have to have a certain amount of gases inside there, or the process of crystallization doesn't take place. And that's why bones, this is a dinosaur bone, right? You can see right here, a big long one that's been cut. The inside of that's all agate, that's quartz. That's the center of the dinosaur bone. Just like this now is all quartz based, so is this. Okay, notice the very center is both these. See, this was all air in here, and this is why you have the pure white crystals growing in.
Oh, okay.
So the air, both bone and wood have air in them. You know, you can take a nail and put it into wood. Why? Why can I, in that tree behind me, can I go hit a nail into it? Because if I try to do it into a piece of metal, the nail's not going to go in it.
Yeah.
There's water going up and down that tree in the vesicles, right? And that water carries air in it. Plus, there's when there's water not there, there's just openings. And so that air inside trees is why petrified wood is the most abundant fossil in the whole world. It's found only on the surface. You don't go down the Grand Canyon and find any petrified wood or dinosaur bones.
Wow.
No bones and no wood in the Grand Canyon, all those layers.
Yeah.
You go down the road and you find petrified wood forest in Arizona.
Yeah, I've been there.
Arizona is really a fantastic state for science.
Awesome.
So your last questions you had for me there?
Yes, I do have another question. So how do you recommend getting started, like for anybody, and studying the universal model?
Good question. First thing we would do, I suggest get this book. It's free and audio online. Like I said, use summary audio for the code. You can get it for free online.
Okay.
Otherwise, it's only $7.95. And this is actually was written by my daughter. She's one of the few people, Brooke McKay, that I allowed to go through all 3 of my volumes. Volume 3, I got about half the chapters done, but I'm still working on those. But she's gone through and given a summary of each of the volumes, okay, what's in there. Like, there's no magma. She has some diagrams in here. Here's the rock cycle, pseudo theory. It's a false theory taught as fact. And then she talks about the hydroplanet model and the flood chapter. Well, all the way through, you're going to see green words in here, and those are questions. And then right after it is the answers. What happened to the dinosaurs? Well, here's the answers. Where did all the water come from inside the earth? Well, there's the answers. What mechanism caused the day-to-day changes in weather? And what is the origin of Earth's high and low pressure systems? Well, right after it is the basics, And you can, so this is a quick, easy way to learn about there's 32 chapters in the book in total, all 3 volumes. Mm-hmm. So it's a real quick way to learn about all of the 3 volumes.